Finding the solution of a quadratic equation, let's quickly review how quadratic polynomials were factorized. The general form of a quadratic polynomial is ax squared plus bx plus c. Here's the first quadratic polynomial. Here, a will equal 1, b will equal 7 and c will equal 12. One of the ways in which we factorized polynomials was by splitting the middle term. The technique was easy. We first write the coefficient of the middle term as the sum of two numbers n1 and n2. And the two numbers are such that their products equal the product of a and c. So can you think of two numbers such that n1 plus n2 is 7 and n1 times n2 is equal to 12? Yes, 3 and 4. 3 plus 4 is 7 and 3 times 4 is 12. So this polynomial can be written like this. The middle term after expansion will look something like this. What we've done here is split the middle term. 7x was written as 3x plus 4x. And how does this help? After expansion, we group the terms like this. And how does grouping help? We look for common terms in each group. In the first group, x is common and in the second, 4 is common. So this can be written as x times x plus 3 plus 4 times x plus 3. Now in this polynomial, x plus 3 is common to both terms. Taking this common factor out from both terms, we get this. So this quadratic polynomial was factorized to this. The two factors of this polynomial are x plus 3 and x plus 4. If you understood this concept of factoring polynomials, then finding the roots of quadratic equations is very easy. Now assume that the quadratic equation we have is x squared plus 7x plus 12 equals 0. And we need to find its roots. By roots, we mean the value or the values of x which satisfy this equation. To find the solutions or the roots, all we need to do is factorize the polynomial on the left. As we've already seen how it's factorized, we can write this as x plus 3 times x plus 4 equals 0. Now I want you to think a bit logically. When the product of a and b is equal to 0, what can we imply? We can say that at least one of them will be 0. Either a or b will be 0. If we apply the same concept to this, we can say that either x plus 3 equals 0 or x plus 4 equals 0. Transposing the constants to the right, we can say that x equals negative 3 or x equals negative 4. These are the roots of this quadratic equation. If you substitute any of these values in this equation, you will see that the equation is satisfied. If we substitute negative 3 in place of x, we get a 0, and it's the same with negative 4. These two are the roots of this quadratic equation. Now why don't you try finding the roots of this quadratic equation? You should get the roots as 2 and negative 3. So the method that you saw was finding the solution of a quadratic equation by factorization. We factorized the polynomial on the left and equated each linear factor to 0. Is there any other technique to find the solution of a quadratic equation? We will see that next.